Hi guys. So this is going to be about the quiz I gave you for today. And in this quiz, this is a simple supply and demand problem. Now we've done several, so I'm going to go fairly quickly this time. It's about machines. So you sell 4 machines for $1,000 each. But if you charge $500, you sell 14. And from this, we can figure out the demand function. So we'll set up our P, Q. I'm going to be no total here, just prices and quantities. And now notice that the prices are big on this problem, the quantities are small. Don't get confused by that. $1,000, you sell 4 machines. $500, you sell 14. Now, so always you should be able to recognize that that's a price. This is a quantity. Okay? Now, we'll do our standard linear math. Okay, 14 minus 4, the difference in quantity, divided by 500 minus 1,000. Difference in price is negative 0.02. That's because changing by $1 here is not a lot. When we change the price by $1, we're not going to create a huge difference in how much people buy. And this is the slope, but it is negative, and that's important. It always should be a negative slope. If we did it by 100, though, that would make a change of 2 machines. Now, I'm going to use this guy because the numbers are easier to work with. So I'll highlight those. And I'm going to use 4 equals negative, the slope, negative 0.10 times 1,000 plus the intercept. Slope should be negative, intercept should be positive. So this guy is going to be 4 equals minus 20 plus intercept. We add 20 to both sides, and we get 24 is the intercept. And so if I got this right, my demand function, d of p, is negative 0.02 p plus 24. And now, this is going to be part of this big problem, so I'm going to check my work by plugging in $500. I'll take this formula, make a copy of it, and put in times 500 and 14, which is this number, so it's a check. That's all I need. So that's my price quantity table, and that's my answer. This guy is my answer to part A. Let's do part B. Okay, so to do part B, we're going to use this part. And we're going to make since that's a supply function, we're going to use prices, quantities, and totals. So the cheapest supplier, which is right here, right, because that's the cheaper number, gives us $300 for each machine, 3 machines, and 300 times 3 means if we buy them out, we spend $900. So the next supplier has 7 machines, and $400 times 7 machines means if we buy them out, we spend $2,800. So the total number of machines, because we're adding up the quantity column, will be 3 plus 7, which is, of course, 10. And the total we spend will be 900 plus 2,800, which is 3,700. So the price of buying out, price per machine then, we spent $3,700 on 10 machines, will obviously be $370. So here are our first price and quantity, and then the other price will be $370, and the other quantity will be 10. And now, let's do some math with that fairly quickly. We'll do 10 minus 3, difference in quantity, divided by 370 minus 300. Difference in price is 0.1 is the slope. It's a positive number. The supply function always have a positive slope. Now we're going to get the intercept. So I'll pick, let's use the first one, 303. Okay, so we'll take this, that 3 equals 300 times the slope, 0.1. Actually, the slope, let's do it in the same order I always do it. 0.1 times 300, the price, plus the intercept. And so that will subtract 30 from both sides, because we know that 0.1 times 300 is 30, and we get negative 27 is the intercept. So at this point, we know, or we think at least, that the supply function is 0.1 times the price minus 27. Let's check that by putting in 370 and see if we get 10. So we'll get, wait a second, okay, we'll copy that down. And you'll see that we do get 10, so that also checks out. So this is the answer to part B. So now, to get part C, we set our two formulas equal to each other. We get the formula for demand. So we find the P that, this is the quantity, and this is an annoying little feature of, okay, try that again. And that's going to equal the supply function formula. So this is so the supply function will give us this quantity with the price to demand. When both of them are the same, we are supposed to be at the same thing. Silly thing. Good. This point, yeah. Okay. And so we solve this by adding 0.02p plus 27 to both sides. 0.02, stop that, go away. P plus 27 to both sides. Now, with a little cleverness, we can cancel these two. We cancel those two. So that makes the left side 24 plus 27, or 51. And the right side is 0.12p. So we divide both sides by 0.12. Can't do that in my head, so I'll just let this gadget figure it out for me. 425 is the equilibrium price. Or it would be if I could spell equilibrium. There. Now, that's the answer to part C. Now, in part D, I want to find the equilibrium quantity. I just plug this into one of these formulas. So let's start with the demand formula. We'll take this, we go back to the original equality, and we plug in times 425. And we get 15.5 is the equilibrium quantity. I spelled it right this time. But to check, it's only equilibrium if we get the same quantity from both formulas. By the way, a fraction is not a bad thing here because we're dealing with an average seller. So sometimes they're going to be charging a little more than 14.425, and so they'll sell 15, and sometimes they'll charge less and sell 16. So on average, they'll sell 15.5. Now, I'm going to plug in 425 into this guy, and if we're lucky, it comes out, and that is a big check goalie. And that's the answer to the quiz.